everyone, and welcome to week 3. As you can see from the PowerPoint slide, it's about learning and teaching scientifically. So hopefully we can have a look at how science has changed over time, and at any given point in time, science is always a measure of the limits of our understanding, not a measure of the ultimate capacity of it. So moving on. Slide number 1, what are we going to look at this week? The learning outcomes. You're going to describe the place of science in a learner's world, explain the ways of understanding science, and identify the learning and teaching of science as it currently stands. We're going to look at the emergence of science as a discipline and as an understanding and a way of knowing. And we can trace this back through ancient history, back to the notion of the Greek mythos and cosmos. Now, Greek society had a really rich mythological tradition. We all know about Homer's Odyssey. We all know about Greek mythology, and mythology was often bigger than cosmology. And in Greek society, the two went together. By mythology, we mean the myths that the community and society had built around their understandings. Cosmology is the science and the practical tools they have for generating that understanding. So in a way, the Greeks were as much empiricists as we are. They're very much a scientific community. And so when we see mythology and cosmology in balance, we can see that society is in the process of evolution. Myth and our understanding of ourselves drives our science. Joseph Campbell, the great philosopher, writes about cosmology and mythology, and of course he's responsible for a lot of our understanding of the value of myth in our lives and society. He says a mature cosmology needs a mature mythology if a society is to grow and develop. And he also points out that some of the problems in our modern understanding go back to the book of Genesis. The Judeo-Christian mythology was frozen around about the year 200 BC, and since it's allowed no scope for expansion. And this happened because the people who chose the story of Genesis, the myth of Genesis, chose it from a network of stories that was a couple of hundred years old already. In Babylon there were other societies, there were other communities that were more advanced. Instead, the Christian myth dated back a long period of time and has probably been stuck there ever since. And your story in this week's chapter about Galileo highlights just how significant that was. In modern days, we see some examples still with birth control, food sustainability, and the spread of AIDS in Africa and Asia. Cosmology, on the other hand, unlike mythology, has thrived. Everywhere we see physicists and neurophysicists opening up new scientific possibilities. So the gap between mythology, between our soul and our conscience, and cosmology, between our science, is widening. And this represents one of the big challenges for teaching science. The study of the natural world, we can see the gap opening, and the study of the human or the social world. We can see a couple of different strands of science listed for us there that come across our understandings. The key terms for this week: narrative, hypothesis, and models. Again, very much what we call empiricist notions. The key questions: what is the scientific method? And we'll go back in history and look at this. How does evidence support a theory? Is theory change in science a rational process? And can we really be said to know that scientific theories are true? All very big questions and key questions. The demarcation problem. Francis Bacon, as you can see there, back in the 16th century, first raised the question, what is science? What constitutes science? And we can see it's broken down in the left-hand column to a whole range of ideologies or isms, as we can describe them. And notice some of the more interesting ones in there. We've got psychoanalysis. In 1899, Sigmund Freud published The Interpretation of Dreams, and as a result, he's opened up a whole range of new sciences: psychiatry, psychology, forensic psychology. Notice that Marxism is listed here also as a science. In a minute, I'm going to ask you some questions about some brave new forms of science. We can see here IQ testing. Is it a science? Parapsychology, acupuncture, homeopathy, biology, economics. What makes a science? Francis Bacon came down to two basic terms: observation and induction. Observation based on a observing, construing a hypothesis, conducting an experiment, producing a law, and that law becoming the basis of a theory. Pretty neat. We can see it here, illustrated in the diagram. We form a hypothesis up here in the top left-hand corner. We collect the data. We attempt to falsify the hypothesis. If we're successful, we form a new hypothesis. From that point, we try to support the hypothesis. How do we do that? We question the phenomenon of nature by setting up an experiment, and we analyse our results. So we can see it's all about creating, justifying and supporting knowledge. And this is what we come to teach in our role as teachers in a science class. But we know there's also no such thing as presuppositionless observation. And I'm sure many of you see something different when you look at that particular illustration. How many squares? Is it a square? Is it a hexagon? What shape is actually there? How many triangles do you see? Okay. Presuppositionless observation, also hard to say. Meaningless shapes, we can make a lot of them on their own. They have no context. A second shape has no context. A third shape has no context. But when we can unify them all into a theory of shapes, or a relationship of shapes, we can see that relationships can create a phenomenon, and a phenomenon can be captured, a phenomenon can be interpreted, and a phenomenon can come to have meaning. We all know what the word fly means. Again, a couple of examples here in the top left-hand corner. What do you see? Do you see the old crone or do you see the young woman? And down here in the bottom right-hand corner, a collection of umbrellas. Now the scientist in me says, is this a new science? Is umbrellaology a budding new science? Can I collect data about umbrellas, about the colour, about who owns them, about the location, about the lifespan of the umbrella, about the gender of the owner, about the age of the owner? And does this actually constitute a viable science? That's what we're here to find out this week. Bertrand Russell, a great philosopher, his whole notion of inductivism, that is, inducting or inducing a theory based on evidence. And he tells this wonderful story about his turkey. The turkey found that on his first morning at the farm, he was fed at 9 a.m. Being a good inductivist turkey, he did not jump to conclusions. He waited until he collected a large number of observations that he was fed at 9 a.m. and made these observations under a wide range of circumstances, on Wednesdays, on Thursdays, on cold days, on warm days. Each day he added another observation to his list. Finally, he was satisfied that he had collected a number of observation statements to inductively infer that I am always fed at 9 a.m. However, on the morning of Christmas Eve, he was not fed, but instead had his throat cut. So there is a little bit of a warning there with scientific knowledge. And Bertrand Russell was hinting again, right back in 1920, about the limited shelf life of anything we call knowledge. These days, knowledge has a shelf life of about 12 months. Karl Popper, came up with the notion of falsification. You'll read about him in this week's readings in your textbook. Gregson talks about Popper, and science is fundamentally about falsifying rather than confirming theories. We keep going until we falsify it. Once we falsify it, it is no longer a scientific fact. Again, hypotheses are a big part. Point 3, if it's falsified, then it's abandoned. But if it's not falsified, this just means that it should be subject to even more stringent tests. So the conclusion is, it is always possible, Point 4, that our best theories will be falsified any day soon. Dmitry Mendeleev came up with a periodic table. And again, the atomic weights and the weights of some of the elements did not quite fit his model. He didn't give away his theory. Instead, he just kept subjecting it to more and more empirical tests and put it down to the fact that it was an error, of an experimental error that led to the failure of his initial theory. Darwin also Again, very controversial theory of evolution at a time when the world was dominated by the church. The lead physicist of the day, Lord Kelvin, said the Earth was no more than 100 million years old, and yet Darwin's theory required an evolutionary period of hundreds of millions in order to be valid. Did Darwin quit? No, he didn't. He set about proving his theory, hence the nature of science. Your textbook activity this week is a good one to get you going. Linda set this one up nicely. Harry Messel. Have a read of the article and complete. Analyse what an old science textbook would look like. I remember growing up as a child, and there was a science show on TV with Professor Julius Sumner Miller. He was an old crone of a man. He was a troll, and he would sit in front of 3 school-age kids, terrifying them about science for half an hour weekly. If you ever have a look at Google Julius Sumner Miller and have a look at how this show went, and it gives you a really, really good insight into the role of science in children's lives. It was a tool of terror. You're asked this week to share 2 major discoveries in science, and Dr. Kirrilly Thompson again was named one of Australia's top 5 researchers under 40 years of age. Now, it's never polite to give away a woman's age, but this is a program and project run by the ABC National, and if you're listening to the ABC National at the moment, they're actually calling for current nominations. Human-animal relationships and natural disasters. Now, we know there's been a range of new discoveries and major discoveries recently. There's been the discovery of a 7-planet solar system, which they believe is the most likely to and most capable of supporting life. We also know that doctors or scientists, in the last 6 months have discovered a completely new organ in the human body. So, anatomical textbooks are being rewritten as we speak. So there are constantly new discoveries happening all the time in areas of knowledge that we thought were fairly complete. The second one here, we've got an example again of another CTU researcher, the Institute for Farming Systems, and Professor Philip Brown. He works in agricultural research and incorporates strategic partners with industry, which of course is the only way research can be funded these days. The Institute focuses on its research activities on 5 agricultural industry areas: sugarcane, cropping, horticulture, beef cattle and poultry. And as we know, I'll put up a little task for you this week in the Zoom collaborative and talk you through it, where we actually look at the role of genetic modification as part of gene modification of plants, to actually have a look at the role that's playing in food sustainability and food futures. So we're seeing major new discoveries all the time. The food genome has been redesigned. We are talking about antibiotics, redesigning the human gene so that resistance to antibiotics can be bred out of our genetic framework. So there's a whole range of new discoveries happening in science all the time. This is exciting stuff. Where to find more? You can see here I provided you with a link to the www.storybehindthescience.org site. Now, this is a fantastic site. I encourage you to go in here as a teacher and have a look, because there are a range of topics, as you can see on the left hand: astronomy, biology, physics, geology, chemistry stories. There are what we call exemplars of practice here, where you can actually have a look at each of these different stories and get the background behind the story. And the important thing here too is you actually get some support materials to use this. There are curriculum materials that show you how to actually include these in your science lessons and in your science teaching. So again, I'll come back to this in the Zoom collaborative on Wednesday and talk you through some aspects of why I think this is a really, really good and very, very valuable and productive pedagogical tool. Science views, activity 4. A really, really interesting notion here, that there are different perspectives. Now, I already mentioned something about the early Christians. The mythology of the Judeo-Christian church actually has been quite closed. And I say that without judgment. If you read Galileo's story, you can see even though he didn't discover the telescope, he was actually put on trial for his life. It was an inquisition, because he dared to challenge the fundamental principles of the church. And the Pope at the time said, no, the only fundamental principle is in the good book. But Galileo said, please, your worship, please, your lordship, look through my telescope at the moons beyond Jupiter and you will see that our universe is bigger. And the response from the Pope, no, what is written in the book is what is true. Now, if any of you ever get the chance, I know that theatre does come to Townsville sometimes. Bertolt Brecht wrote a brilliant play called Galileo, and in it he actually dramatises this whole confrontation with the church and the courage that took for Galileo to do. Muslims, the Ottoman goal in the 19th century has remained more or less the same, gaining power through technological advancement. Indigenous perspectives, powerful tool. Up in Cairns, where I've lived for the last 16 years, the Jabbergai people have a wonderful tale about the two spirit brothers. And of course, the naughty brother was the name went by the name of Damari. And Damari ultimately has an encounter with Ganyara the crocodile, who bites off his leg. And this is why Indigenous people these days are taught to be fearful of crocodiles and to be cautious. But after his leg is bitten, Damari climbs the mountain range behind Cairns and lies down and slowly dies. But on the way, his blood spills from his wound and gives rise to the ecosystem, gives rise to the social system, gives rise to every system, fauna and flora around the Cairns region. So it's a beautiful creation story. Is it science? Or is there room in science for stories like this? I would argue it's probably not that far away from the early Christian stories. paradigm shift. We've seen science shift and change its disguise over many years. The Aristotelian physics went to Newtonian mechanics. Geocentric, heliocentric model of the universe. Remember, we used to think that the universe moved around the Earth until Copernicus actually stood up and said, well, it's the other way around. The Earth moves around the sun. We've had the Darwinian revolution, again, which challenged the authority of the church. And Newtonian mechanics, okay, and Einstein's theory of relativity, the rigid form of Newtonian mechanics versus the much more flexible and chaotic science of Einstein. So we've seen paradigm shifts change the way we view science. And these days, of course, we have people like Stephen Hawking promoting what we call quantum mechanics and quantum physics. Again, Einstein's theory taken to elaborate levels of application. Thomas Kuhn, a little quote worth throwing in here for you to help you come to terms with this. We're not the first ones to think or be confronted with the notion that science is a slippery thing. The history of science may be tempted to exclaim that when paradigms change, the world itself changes with them. Led by a new paradigm, scientists adopt new instruments and look in new places. Even more important, during revolutions, scientists see new and different things when looking for familiar instruments in places they've never looked before. New planets, new species, new body parts. It is rather as if the professional community had been suddenly transported to a different planet, where familiar objects are seen in a different light. These considerations raise questions about truth and objectivity in science. This week we get to look at science as a moving target, Activity 5. And for instance, I grew up, the first record I bought cost me $1.10. It was a T-Rex song called Metal Guru, and the year was 1972. And I earned that $1.10 by mowing lawns for 3 weeks. I was delighted with that. Now I'm linked to iTunes. And I've got, even on my telephone, I download, I create playlists, a whole range of different evolutions. It is a moving target. Have a go at Activity 5. Narratives. We come to the narrative task on page 109. Select the conflict area, share your response or ideas on the discussion board. I'll create a direct link in the distance student discussion board for this to happen. And let's see what you come up with in terms of some conflict areas. Activity 7. Focus question on page 109 of Gregson. List 5 activities to investigate science and technology of any object. And here's a wonderful example of a tent given by Linda. Okay? Tent material needs to be waterproof. How can you test it? Living things need shelter to survive. Mass supported by poles. Strength to withstand wind. Storage. And you can see there's a couple of activities there to investigate science and applications. Pick your own object. Apply your own rigorous tests and hypotheses. The final point I want to come to this week is a TEDx presentation. And Atif Kukasawadi from Queen's University does this wonderful presentation about the need for new stories in science. He argues that it teaches facts well, that it has a rich history, it has a lot of applications and a lot of contexts, but he's raising a case here for storytelling in science. And this is something that I want to pick up in the Zoom session this week. It's a really, really powerful, I think this is a really, really good TED Talk to watch. It's only short, it's only 8 minutes. The link is provided for you. But again, he goes to show how the use of stories can make science communicable in a way that brings it and opens it up to new paradigmatic or new audience shifts. I'll leave you with that thought and look forward to seeing you in the Zoom session on Wednesday at 10 o'clock, where we'll pick some of these issues up and where I've also promised to break down the assessment criteria for you. Thank you very much.